Alright, matrices. Alright, so a matrix is basically just a rectangular arrangement of numbers. They're pretty handy though. There's lots of things that you can do with them. They're pretty useful with solving systems of equations, especially computers like to put arranged numbers in a matrix. They're pretty useful. We're going to just do some basic stuff with them today. We're going to add them, subtract them. We're going to do some scalar multiplication, and then we're going to actually try to get into matrix multiplication, but I don't know if we'll have enough time. But we're definitely going to add and subtract matrices and do scalar. I'm pretty sure matrices are going to be on, if you take the CLEP test, you're probably going to see matrices on there. Anyway, this is what a matrix looks like. Let me just make one up.
I'm glad it like had Morpheus in there.
No. Okay, so that's a matrix. Okay. These are rows. And these are columns. And when you give the size of a matrix, you give rows by columns. So this is a 2 by 3. That's a 2 by 3 matrix. Okay? And each little piece in here, like each one of these, that's called an element. So rows go like in the theater, the rows go this way. That's how the rows go. And the columns stand up and down like columns in front of a big fancy mansion. Alright, so rows and columns. And they all have to be 2 by 3. Okay. You name a matrix with a capital letter. Like this could be matrix A. And then from then on, when I say, once I change it, when I say, okay, matrix A, you're going to know I'm talking about this 2 by 3 matrix. And we name them with capital letters. Equal matrices have equal elements. So, if I tell you that A is equal to B, then B is this exact right here. It's exactly the same. If matrix A equals matrix B, all the elements are the same. So if B is like, this is what they like to do, is things like this. I've run out of alphabet. There we go. We can say, oh, well, they're equal. Okay, well then X, that means that 2x is the same as 5, so x has to be 5 over 2, and that's the same. Y, what does y have to be? 2. Z has to be 6/5, and W would have to be -8. So if they have, if the matrices are equal, then their elements are equal. Okay? Does everybody have that written down? No, some people are sure. I'll give you a second. 1. Got it? Let me just pause this so you can write. Okay, you can add and subtract matrices. You can only add and subtract matrices that have the exact same dimensions. If they don't have the exact same dimensions, you cannot add them and subtract them. So matrix A.
Thank you.
Alright, so these are my three matrices, A, B, and C. Matrix A, what are the dimensions on matrix A?
2 by 3.
2 by 3. What are the dimensions on matrix B?
3 by 2.
Can I add them together? No, because they are not exactly the same. They have to be exactly the same. This one's a 2 by 3, right? So I could add A and B. I mean A and C. I could subtract A. I'm not gonna lie, matrices are gonna eat up paper. Some more paper. Just be ready for it. Especially when we start multiplying them. So to add them, you just add corresponding elements. Like this 2 is in this upper left corner. I'm going to add it to the same spot over there. It's going to be 2 plus negative 1. What does the 3 get added to?
Minus 8.
Uh-huh.
5
Negative
5.
5. 6 would be
13.
added to 7, which would give me 13.
12.
1 plus 11. 4
19.
plus 15. And then negative 9 and 12. Alright. You do, let's mix it up. Do C minus A. Do C minus A on your own. Subtract each of the corresponding elements. Okay?
Yep.
Alright, let me write this down. So what? So C. That started copying like right as you walked up there. I was like, how did she copy that? Alright, so what's right here? Negative 3. You guys are genius. Genius.
Doesn't seem too bad.
Yeah. It's not bad. It's not going to be bad. I promise.
Are you saving the easy stuff for the end of the year?
No. No, this is just... Actually, I'm going to give you a little bit of multiplication. This is not matrix multiplication. Matrix multiplication is where you say, here's matrix A, multiply it times matrix B. We're going to do scalar multiplication, where we are multiplying one number times everything inside the matrix. It's kind of like distributive property. Well, it really is distributive property. Like 4B. That means I'm going to multiply everything inside matrix B times 4. 4B would equal 8, 32. I'll actually be able to write 32. 4, 28, 16, 24. That's scalar multiplication. Just whatever that number is times everything inside that matrix. And as far as the order of operations, like if you have 5A minus 3C, order of operations, you would have to multiply 5 times everything inside of A, 3 times everything inside of C, and then subtract the 2. You have to follow order of operations. But it's time consuming, but it's not difficult because it's just a bunch of one-step things. Like, let's say you'd have 10, 15, 30, 5, 20, negative 45, minus negative 3, negative 24, 21, 33, 45, 36, and then subtract. So it's not difficult. It takes a little bit of time, especially when you don't know your multiplication facts. That's going to take you a minute, but it's not difficult. Okay. Um, as far as properties that work for addition, commutative property still holds true for a matrix. Um, associative property still holds true for addition. Additive inverse, additive identity, all those things hold true. Um, subtraction, no. You cannot, if I multiply, I'm sorry, if I subtract C minus A, I'm not going to say answer is A minus C. That's not true. So you can't do subtraction. Pretty much the same as like regular numbers. Yes. That's probably. I don't think I want to try my matrix multiplication today. I'm going to do matrix multiplication tomorrow, I think.
I like those words. Do it tomorrow.
Alright. Yeah, we'll actually multiply matrices